Hello everyone, in this video we're going to discuss the questions regarding Doppler's effect. Let's get to it. A police car parked by roadside sirens with a frequency of 1000 Hz. If another car is driven towards this police car with a velocity of 33 meters per second, determine the apparent frequency of the siren heard by the driver on the oncoming car. So the speed of sound in the air given here is 330 meters per second. Let's do the listing. We have here the frequency 1000 Hz. We have the V of the observer is 33 meters per second, and obviously the source is 0 meters per second. So we're going to use negative O as positive. From here, the one that is moving is the observer towards the source. Hence, our equation Fe equals to V plus VO over V times F. Then we're just going to substitute. And the answer is 1100 Hz. Question B. If the car is now moving away from the police car, calculate the apparent frequency. Alright. So again, we're going to use negative O as positive. This time again, the observer is the one that is moving, but this time away, hence we got the negative. This is our equation. We're going to use the negative here. Then we substitute. So the answer is 900 Hz. Question C. By referring to A and B, sketch the graph of the frequency versus distance. We're going to sketch the x-axis as the distance, the unit is meters, the y-axis is the frequency, the unit is hertz. So we're going to add in the value of the coming and the move away. Here is the 1100. Here is the 900. And here is the actual frequency. If the car is now stationary, but the police car is moving towards the car with a velocity of 33 meters per second, so basically the velocity is still the same, what's going to happen to the siren heard by the driver inside the stationary car? Alright, negative O as positive. This time the one that is moving is the source and it is towards the observer, hence we're going to get negative. This is our equation that we created. So the answer is 1111.11 Hz. Again, this is for question D. Next question, a sound source which can produce a frequency of 300. Alright, we have 300 Hz. Move away from a stationary observer. Negative O as positive. The source is moving away from the observer, so we got positive. Interesting part in this question, dia kata the observer noticed that the frequency of sound changes by 10 Hz because this one is moving away. And if we refer back to our graph of a frequency versus distance, for moving away, apa yang berlaku ialah pitch akan jadi lower. So instead of kita sekarang ni tak tahu. Sekarang ni cerita dia ialah ada 300. We don't know if we want to add 10 or we want to minus 10. But because for moving away, it is actually pitched down. Okay, pitch down. So we're going to choose the 300 minus dengan 10. But before we go to that part, we're going to make the equation for this one. Okay, because this one is positive, our Vs is positive, Fa. Now we're talking. So the 300, like I said, because it is moving away, okay, it is moving away, maka kita ambil yang lower pitch. So kita kena tolak. So 300 tolak dengan 10. So I got 11.26 meter per second. Question number 30B. A person who stands by the side of this train track finds that apparent frequency of the train whistle changes from 630 Hz while the train approaches from the person from afar to 580 Hz when the train passes by her and moving away from her. So I'm gonna say apparent frequency of the approach is 630 Hz, and then apparent frequency of moving away is 580 Hz. Because the source of the sound, which is the train, is the one that is moving, so negative OS positive, the source is moving towards, approaching, right? So towards, so the apparent frequency equals to V over V minus Vs darabkan dengan F, sedangkan yang ini pula negative OS positive, sekali lagi the source is moving but then moving away, right? Moving away, so FA equals to V over V plus here Vs darabkan dengan F. So we are not given the real frequency of the train, but then it's okay. I'm gonna change this one as the subject of the equation. So now that I've changed the F as the subject, I'm gonna combine these two together. This is it. And now I want to cancel the speed of sound because they are the same. And next I'm gonna do the substitution like this. And then I calculate, and I got the Vs as 12.4 meter per second. For question number 31, we have a bat flying at 5 meter per second towards a wall, emits a chip at 50 kilohertz. If the wall reflects this sound pulse, what is the frequency of the echo received by the bat? Now this situation requires some sketching. So let's do the sketching. This is my wall. This is my bat. So the bat is approaching the wall at 5 meter per second and emits a frequency of 50 kilohertz. In this case, we have two situations. The first situation is when the bat emitting the sound wave to the wall. Now in this case, the wall becomes the V of the observer and the bat is the V of the source. So we're going to use negative OS positive as the source is moving towards the observer. We can see it is negative. So this is our equation. But this is not whatever that value that we're going to get later. This is not the frequency heard by the bat because the sound waves later on reflected to the bat. So our sound where we get the apparent frequency apparent here now becomes the real frequency, and then the reflected real frequency, the real frequency heard by the bat. So later on we're gonna change this is as the V source, while this one becomes the V observer. So V source now becomes 0. This is the first situation. I indicated in blue color as the reflected sound. I'm going to indicate it as the pink color and red color. Observer for the second situation is 5 meter per second. Now we're going to create the equation for the red situation. Negative OS positive. Now this time the observer is the one that is moving towards the source. The source is the reflected sound, which is from the wall. Okay, so FA equals to V. This time the bat becomes our observer. So the equation is like this. Now let's do the calculation for the first one. So this is the answer for the apparent frequency heard by the wall. Now this one now becomes the real frequency of the wall. So we do the substitution, but this time we're gonna take this one 507,969.23 as our real frequency, and finally our answer is 51538.46 Hz. Let's move to question 31b. A whistle giving out 500 Hz moves away from a stationary observer in the direction towards a vertical concrete with a velocity of 1.5 meter per second. Determine the frequency that heard by the observer. Again, it is helpful if we can do the sketching. So here I have the wall, here I have a whistle, and a person. The whistle is moving towards the wall. Question 1 asking for the apparent frequency directly from the source. So we have to find the frequency here. So we can see that the source is moving away from the observer. The source is moving away from the observer. What do you think is the equation? Did you get this one? If you got it, then good. So now we're going to do the substitution, and the answer is 497.74 Hz. For the second part is we have to find the apparent frequency after it is reflected by the wall. So this time the sound is hitting the wall and it is reflected back to the person, which is the observer. Now notice that there's a relative motion between the whistle and the wall, hence we're going to have the apparent frequency. But the wall and the person, which is the observer, they both don't move. So whatever sound reflected is the same as the apparent sound heard by the wall. So they are the same. I'm going to use negative, OS, positive. It is the source that is moving towards the observer. Notice that this one, the wall, also the observer for the person, because they both are not moving, so the sound are the same. So FA equals to V over V minus Vs, and then times dengan frequency, we do the substitution, and the apparent frequency is 502.28 Hz. Next question is question number 32. Figure 7.9 shows a police car with its siren on is moving to the left at 35 meter per second. The siren emits, okay, this is the frequency, and they also give us the speed of sound, but this one is a little bit different than the 330. This is 343. So I'm gonna do the listing. Because this is a police car and it has a siren, this is the V source, 35 meter per second, and then the frequency and the speed of the sound in air is 343 meter per second. Question A is asking for the distance the car moves in one period of sound. So before we get to the velocity, we have to find the period. We can get the period by using 1 over f, and the answer is 4.55 times 10 to the power negative 3 second. And now kita boleh cari kita punya velocity of the car. We know that the velocity equals to displacement over time times, saya terus letak period, and then kita masukkan nilai dia. So the displacement of the car is 0.16 meters. Question B is asking for the distance again, but this time for the sound wave that travel in one period. Because the period is the same, I'm going to use the same equation and the same period, but this time different V. If this one is the velocity of the car, this one is the velocity of the sound. So the sound can travel up to 1.56 meters with the same period. Question C is asking for the wavelength of the sound. So this one is quite straightforward. We're going to use V equals to F lambda. Remember, we're going to use this frequency of the sound, hence we're going to use this one. And this is our lambda. Just now, I was pointing to this part here, when the fact that it was actually this part, but luckily it was the same, which is the lambda of the sound and the frequency of the sound. Alright, now this time, question D is asking for the frequency of the sound perceived by a person standing behind the car. So we know that the car is moving to the left, right? So the person is standing behind here. So this is basically the observer standing. It's not moving anywhere. And we're going to use negative O as positive. So we can see that the source is the one that is moving, and it is moving away from the observer. So we can get positive. Can you guess the apparent frequency equation? Did you get this? Apparent frequency? If you got, congratulations. And now let's do the substitution. So the apparent frequency heard by the observer that is sitting behind the car is 199.63 Hz. And lastly, question E, frequency of a sound as perceived by a person at the bus stop when the police car approaching him. So I'm going to do the sketching first. We have a person sitting at the bus stop. For the stretch string, we can see that this one is the basic, which is the fundamental, which is note, anti-note, note. So when we do for the third harmonic, is it the third harmonic again? Yeah, for the third harmonic, we have to start with the first harmonic, second harmonic, third harmonic, like that. And then we're gonna sambung this one, the shadow. For sure, we're going to label note, anti-note, note, anti-note, note, anti-note, note. Question B, asking us to determine the speed of the wave in the wire. So this is basically the transverse wave. Okay, so we're going to use the equation that we can see from the note, V equals to set T over mu. But because we have mu is M over L, I'm going to combine the two. So we got T over mass over length, like that. And the answer is 365.15 meter per second. Question C is asking us to obtain the frequency of the sound generated by the wire. So this is the third the third harmonic. So question C, F3 equals to the basic equation for the nth harmonic is Fn equals to Nv over 2L. So because we know that this is F3, third harmonic, we're going to straight away do like this. And let's do the substitution. So the frequency for the third harmonic is 730.3 Hz. The last question, calculate the frequency of the sound at C as heard by the observer approaching the wire 2 meters per second, given the speed of sound in the air is 340. So remember that speed of sound, depending on the question, they will give it to you. We're going to use again negative O as positive. Based on this question, it is the observer that is approaching the wire with the speed of 2 meters per second. So the observer approaching the wire. So the equation is like this. Now let's do the substitution. The real frequency, we can take it from the question C, 730.3. So the answer is 734.6 Hz. Notice that this one is higher than the real frequency, which match with our base the Doppler's effect. We can see as it approaching, the apparent frequency is higher than the real frequency. And that's all.